Okay, guys, we have this is what I posted. We did in the class. So number one, they ask whether this is continuous or discrete random variable. Now, the first question was number of phone calls. Now, anything you can count is discrete. Okay, discrete, since you say since number of phone calls okay, number of phone calls can be counted. Okay, now next one is pH level shampoo. You don't really count the pH level. You know, it can take all kinds of value. It is continuous. It can be 4.2, 4.201, 4.235. It's not counting. Okay, we're not counting the pH level. It can take all infinite number of value. So it is continuous. Okay, continuous, since we don't count. Like count means 1, 2, 3. We don't count the shampoo pH level. Okay. Now number 3. Now it is they want you to find the whether it is property distribution. That means you add all these. If the sum is equal to 1, then yes. If the sum is not equal to 1, the answer is no. Okay, so you have to just found all those four numbers. What I'm saying is 0.3, 0.037 plus 0.200 plus 0.444 plus 0.296. Okay, you gotta add them up and check. Next one is they asking the mean. So mean is you put all the x's in L1, p of x in L2. In L3, you put L1 times L2. Okay, and then you add the numbers in L3. So let me show you in the calculator. So here, so hit stats. You gotta turn the calculator on. Okay, stats. Okay, you clear L1, clear L2, might as well clear L3. So now in L1, you put all those numbers 3, 6, 9, 12, 15, 3, 6, 9, 12, 15, and then corresponding probability, which is 0.14, 0.11, 0.36, 0.29, 0.1, or 0. Okay, so now you go to L3, you highlight L3, and second L1 times second L2. Okay, and then what do? You got to add the numbers in L3. So let's go to stat, calculate, hit enter, and L3. Okay, so that is if you hit enter, now sum of L3, the sum is, what number did you see? I believe it was 9.3. Is that right? So 9.3. So it is 9.3. So that the answer is B. Okay, let's go to number 5. Police department reports find that probability of 0 to 3 burglaries will be reported in a given day is that. So find do the same thing. Okay, you do. I'm not gonna do it this one. Oops. So this is, you put what are you going to put in L1? L1 is 0, 1, 2, 3. What are you going to put L2? That's L1. L2, you're going to put what? 0.5 and 0.38 and 0.11 and 0.01. Okay, and do the same thing as number 4. Number 5, find the variance. Now variance, so what is the variance? Variance is standard, STD means standard deviation, square of standard deviation. Okay, so your calculator will give you standard deviation, this one first. Okay, so let me show you how to find the variance in this case. So open calculator again. Now you gotta clear everything, go to stats, edit, and then again you clear L2, L1. Okay, now L1 is the number 0246, 0246, and then L2 you put 0.05, 0.17, 0.43, 0.35. Okay, and then now to find standard deviation, you go to stats, go to calculate, hit enter, second L1 comma, second L2. Okay, then you get 1.6895. So will be 1.6895. That is standard deviation. You square that. Okay, so again, let me put that in the calculator. So let me clear it. 1.6895. If you round it, 1.6895. You square that, you get 2.85. So that is, do we have 2.85? Yes. So that equal to 2.85. Number 7. Now police department reports, find the standard deviation of that. So again, I just did it in L1. You put what? 0, 1, 2, 3. In L2, what do you put? The probability 0.52, 0.4, 0.07, 0.01. So let's try that. So here, stats, edit, clear. Okay, we all clear L3. So go to L1. Now what are you going to put? 0, 1, 2, 3. 0, 1, 2, 3. And then probability, what is it? 0.52, 0.4, and 0.07, and 0.01. Okay, oops, 0.01, 0.1. Okay, so now after you do that, you gotta, what did I say? Go to stats, go to calculate, second L1, comma, second L2. Okay, so then you get, what is it, 0.667. So 0.667, you round to 0.67, which is B. Okay, in a game you have 1/40 chance. Okay, we expected the value. So we usually use expected value to find, when you gamble it, how much you win, how much you lose. So expected value is positive, that means you win. If it's negative, you lose. The formula is probability of win, and the money you win times minus probability of losing, and then you lose money you lose. So in this example, probability of winning is very low, which is 1 out of 42, because why? 1 minus 42, 1 minus 41 out of 42 is 42 out of 42 minus 41 out of 42, which is 1 out of 42. So that time, how much you win? If you win a lot of money, $67. but probability of losing is 41 out of 42. And lose your bet, which is what? $7. Okay. So if you do that in your calculator, okay, I'll do that in the calculator. So you do it, you're on. This one I don't have to show times. I get negative, so I get negative, if I round it, negative 5.238, so round negative 5.24, okay? So that means you're gonna lose that much money every time you play the game, okay? All right, so let's get to the next page. This is the first page. Go to the next page. I gotta bring the next page here. Okay, so it was 5.2. Which one is second page? Is this second page? Which one is second? Second page is, oh, this is second page, looks like. Okay, so now, and I need to get rid of the first page. It's kind of, okay, so this is here, and this page need to delete. Okay, good. So I get second page here. Now I'm going to erase that. Okay. Now second page starts with find the probability of selecting exactly 8 goals. Hey, pretty easy. You know, 8 goals is right there, 0.183. Find the probability of selecting 12 or more. So 12 or more is this 12, 13, and 14. So 12 or more is 0.022, you know, start from 0.006, 0.001, 0.000, so 0.007, so 0.007 is the answer. Okay, number 11, find the probability of selecting 2 or more. So 2 or more means probability of 2 or more. I mean, you can add starting from 0.06, 0.022, 0.061, 0.122, all the way to 0.000. You can do that, or 1 minus probability of 2 or more. The other way is 1 or none. Okay, you have 0, 1, 2, all the way to 14. Okay, so 2 or more is this. This is 2 or more. This is 1 or none. So probability of finding 2 or more is 1 minus probability of this. Okay, so it is 1 minus. What is the probability of 0? Is 0.000 plus. What is the probability of 1? 0.001. So it is 1 minus 0.001 will be 0.999. Okay, so that is 0.999. Next one. First group of 12 people are selected to discuss the product Yummy company. You determine that, okay, so they're asking, would it be unusual to select 12 people and find that fewer than 5 recognize? What this question is asking is this. Okay, now what this question is asking is, if you have, let me just move it. Let me write on this side, this one. So you have, okay, the mean number is, there's a mean number is 9.4, standard deviation of point, so this is 9.4, and let's say this is 9.4 plus 2 times 0.98, because that's standard deviation. This point is 9.4 minus 2 times 0.98. Okay. So now, then, we got to calculate these numbers. So 9.4 plus 2 times 0.98, you get 11.36. That's 11 point. What happened? These things are so strange. So this is, I gotta get a new pen, okay? So this is 11.36, and this point is 9.4 minus 2 times 0.98. It is 7.44. 7.44. Okay. So now they're asking 5, fewer than 5. Where is the 5? 5 is way over here. I mean, if I extend a little bit more here, 5 is way over here. This is 5. 5. So number between these two numbers is usual. It is what they're asking. This is a usual number. Outside is unusual. Okay, since 5 is outside of 7.44 and 11.36, it will be what? Unusual. Okay, since 5 is less than, what is it? 7.44. Okay, so that's what you have to say. All right, next question. Okay, next one is determine whether the given procedure result in binomial. So rolling a single dice 19 times, keeping track of numbers that are rolled. It's not binomial. It's not binomial. Why? Because there are 6 outcomes. Rolling by 6 outcomes. There are 6 outcomes because outcomes are what? 1, 2, 3, all the way to what? 6. Because when you roll a dice, you know, the dots on the top can be 1 through what? All the way to what? 6. 2, 3, 4, 5, 6. Okay? So it is not binary. The answer is not binary. There are more than 2 outcomes. The answer is A. There are 6 outcomes. Rolling single die 40 times, keeping track of 5. This is yes, binomial. Why? Because you have either 6, not 6, 5, they say. So either you're gonna get either 5 or not 5. Okay? If you get 1, 2, 3, 4, 5, yeah, that belong here. If you have 1, 2, it belong here. If you have 1, 2, 3, it belong here. Anything other than 5 belong to not 5. So we have 2 outcomes only. Okay, 2 outcomes. Then it is binomial. So procedure binomial. Okay, it is binomial. Answer is A. Okay. All right. Let's go to next page. Oops. Go to. I don't know why I have to do this every time I have to do. So this is believe. Oh, this last page, I guess. Good. Okay, insert. Right now, this one I need to get rid of it. Okay. Now, the last one. in choosing 5 people from a group of 59, 15 are women, keeping track of numbers of men chosen. 5 people from a 59. So you got, looks like, wait a minute, why this one's still here? So let me erase this. Okay. This from the previous. Okay, let me just see. Let me erase that. Okay. Okay, so bring it back. Okay, here. Oops, went too far. Okay. Okay, now, so this question is, okay, this question is whether it's binomial. Choosing of 5 people without replacement from a group of 59 people, 15 are women. So we have, oh, this is not. So because this is, you have 15 women, then you have 45 men, because together they have 59. Okay, so now when you choosing 5 people, so when you choose 5 people without looking at them, and then you can have, you can have a 0 man, you can have 1 man, you can have 5 men, there are all kinds of outcomes. 0, 1, or 2 men, or 3 men, or 4 men. You get 0, 1, 2, 3, 4, 5. You get 6 outcomes. So here, every time, because you do without replacement, okay, so every time you do, probability change. Okay, number of men changes, because you every time you take out 5 people are less. Okay, so probably keep changing it. So binomial, it's not binomial. The trials are not independent. Try more than 2 outcomes. Try binomial is not so many. There are too many trials. No. Procedure resulting, but no. Answer is A. Okay, it should be independent. Okay. 17. Assume that procedure, okay, now, so what that means here is, what that means is you try 4 times, okay, probability of getting X is, this means out of 4 try, and you have 1/6 of chance of a probability. In other words, you have this is, the formula goes like this. This is binomial probability. So it is binom PDF. It is n comma x comma no npx. The order in your calculator order is npx, n, and then px. Okay, what they mean here is, the meaning of that is, let me find the example of that. Example is, when you try 4 times, and probability of winning is 1/6. So this question is, what is the probability of winning 3 out of 4? Okay. So if you use a calculator here, you go second bars up here. Oops, let me turn on the calculator. So second bars, you see, you gotta go down a little bit. You need to see binom PDF, okay? Binom PDF. And then they have a parenthesis, so you need to put, binom PDF and one number. You gotta put, 5, 1, 6, and 3, okay? Let me show you again here. So now I hit enter, and then let me clear so you can see the whole thing better. Not stats. I said second bars. You're going distribution. DSITR, the yellow. So you go down, binom PDF, and then 5, 1 divided by 6, you can put fraction. And no, it's not 5, it's 4. It's 4. 4, okay, so let's go back. So it is let's do it again. Second bars, go down, binom PDF, 4, 1 divided by 6, and then 3. Okay. Then you get 0.1543. Do you have that? Yes. So answer is D. Okay. The example would be you try 4 times. Okay. So you can have, what is the probability of out of 4 try when you get 3 success? Each success probability is 1/6. That's what it means. Okay. So this one, you do the same thing. So binom PDF. In this case, you have to put what? 5, 0.7, 2. Okay. Put that in your calculator. Number 19. A test consists of 10 true, false. That means true, false means what? Probability is 0.5. You either correct or wrong. True, false. To pass the test, students must answer at least 7 questions correctly. Okay. If you can guess each question, what is the probability of students will pass? So, to pass, okay, probability of passing is probability of 7 correct, probability of 8 correct, plus probability of 9 correct, and probability of 10 correct. Is that right? Because at least 7. So now, what you have to do is, you can do individually. You get the number. So this number is binom PDF. This would be 10.57 plus binom PDF of 10.58 plus binom PDF of 10.59 plus binom PDF of 10.5 and 10. You have to add all this. Okay? You can do it. So, or you can do 1 minus probability of 0 to 6 correct. Is that right? Okay. This one, from at least, if you, as long as you start from 0, then this is 1 minus, now use different formula here. Different function. Binom, we say CDF, the one next to it. And then NPX. So that means 1 minus binom CDF, you get 10.5 and then up to what, 6. So let me show you calculator. So let me move this one over. So 1, okay, let me clear up. 1 minus second bars, you go down binom CDF, and then 10, comma, 0.5, comma, 6. If you do that, you get, did you see the number? 0.171875, 0.171875. If you round it, it is, what is it? 0.172, which is 0.172. Okay? So remember the question, you know, the wording of the question. Now, it's much easier than adding these 4 numbers, okay? So, remember this formula right here. Okay? So next one is, in a certain college, 33% of physics majors belong to ethnic minority. If 10 students are selected from the physics major, is the probability what? That is probably that no more than 6 belongs to an ethnic minority. Okay. So now, so I'm doing number 20. Oops, I want to use this. So number 20 is, you know, probability of ethnic is 0.33. So probability of not ethnic is 0.67. Okay, so 1 minus that. So what is the question? If 10 students say what probability of no more than 6? No more than 6 means what? 0 to 5. Okay, no more than 6. So 0 to 5. So probability is no more than 6 is probability of 0, probability of 1, all the way to probability of 5. Now, these you can use binom CDF. Okay, so now from the calculator, I can just, we don't have to subtract 1 like the previous one. This one you can go straight using calculator. So I clear that. So go to second bars, go to binom, next one CDF, and then what do you do? Binom CDF, what is it? N is how many? You pick 10, and then so no more than 6 belong to ethnic. So no more than 6. So ethnic is 0.33, right? So it is 10, 0.33, and 5. Okay, so you put that in the calculator again. So 10, comma, 10, comma, 0.33, comma, 5. Okay, you get 0.926. Do we have that? What was that? 0.9267. Do we have it? 33% ethnic minority. If 10 people are selected, no more than 6. Okay. Oh, no more than, so we gotta go up to 6. So plus no more than 6. Oh my God. 6. So this number need to be changed to 6. Okay. So let me do it again. Sorry about that. So go there and then clear, and then second bars, go to binom CDF, and then we should put 10, comma, 0.33, comma. Hello. 0.33, comma 6. Okay. Then you get 0.9881. Do we have it? 0.9815. Yes, 0.9815. Okay. All right. You had, did you see the number, by the way? Hold it there. 98145. 98145. So when you round it, it is 0.9815. Okay. All right. Next one. At the airline, what is the probability the number who show up will exceed the capacity of the plane? Okay. This is also a good question. Okay. So let me move it on this side. Okay. To this question. So it is now 98% of people show up. In other words, when 100 people made a booking, 2 people don't show up. 98 show up. Okay. Now, if an airline booked 76 people on a flight, for which the maximum is 74, is they overbooking? 2 people not gonna have a seat if they all show up. But like I said, probability says not everybody show up. Lynn, I'll call you right back. Okay. So probability is what is probability that the number of people show up will exceed. So exceed the probability of, let me do this one here. Probability of exceed is probability of, now they only have a 74 seats, right? 74. Okay. But they have only 74 seats. Okay. And what is the probability that, so if they have 75 show up, then they're in trouble. And then also 76 everybody show up. Then they're in trouble. That's what probably they exceed, because they only have 74 seats. So now, 75 showing up is binom. Okay. Binom CDF, because 0 to 75 people show up. Okay. So 75 show up. So 75 show up means out of how many? 76. Probably showing up is 98%. 75 plus everybody show up. 76.98. 76. Okay. So you gotta this is binom, I forgot. Binom. Oh, this is a PDF. Sorry. Why I said CDF. So this is binom PDF. So now put in your calculator again. So now clear. This is how you do it. Second bars, go down to binom PDF, hit enter, and then 76, 0.98, 75, close parenthesis, plus another binom. Okay, important. Second bars, go down to binom PDF, 76, comma, 0.98, comma, 76. Everybody show up. Then you get what was the number? 0.5494. 0.5494. Do you have the answer? 0.5494. Okay, that's the answer. Right. Let's do 22. A machine has 9 identical components which function independently. The probability that component will fail is 0.2. One component fail is 0.2, but we have 9 components. The machine will stop working if more than 3 components fails. More than 3, so 4, 5, 6, 7, 8, 9. Find the probability the machine will be working. So you gotta think this one a little bit. Okay. The probability of working is probability of how many fail? It will work as long as, okay. No, if stop working. Probability of working is probability of 0 fail plus probability of 1 fail plus probability of a 2 fail, all the way to what? How many fail? Because if stop working, if more than 3 components fail, more than 3. So it's okay. Probability of 3 can fail. Is that right? Okay. Up to 3 fail is fine. Then it will be working. 0 fail, no, of course it won't. Okay, so now now you can use, because as long as start from 0, you use binom what? CDF. Oops. Man, this is terrible. Why is that? They think I'm drawing the circle or something. So this is binom CDF, and then what is it? NPX. So that is binom CDF. What is N? How many machines altogether? 9. And then probability of failing is 0.2. X is up to 3. Okay. So you put in your calculator. So again, I'm going to clear this. So second bars. So binom CDF. So you get N is 9, 0.2, 3. You get 0.914. So 914,358. 0.914358. So answer would be what? 0.914, isn't it? 0.914. Okay? All right. Now let's look at so this is that question. Okay. Now the participant in the television quiz show are picked from a large pool of applicants with approximately equal number of men drawn. Among the last 11 participants, there have been only 2 women. If participants are picked randomly, what is the probability of getting 2 or fewer women when 11 are picked? Okay. So now, I'll do it over here. So probability of 2 or less woman. Okay. So that is probability of 0 woman plus probability of 1 woman plus probability of 2 women. Okay? So now, but what is the probability of picking a woman? Because there are the 11, only 2 women, so 2 out of 11. Okay, so probability is 2 out of 11, 2 over 11. So this probability is binom. Now you can do CDF because starting from 0. Okay, so 11, 2 over 11, up to what? 0, 1, 2. So you go 2. Okay, so go second bars, and then just enter the number 11, comma 2 divided by 11, comma, and 2. Okay, then you get 0.6777. Do you have the answer? So 0.67758, 0.67758, I believe. Okay, so which is what? Do we have the answer? Wait a minute. Getting 2 or fewer. Out of 11. Okay, so .667. Let me try again. Did I enter the correct number? Yeah, 11. There are 11. So 2 out of 11. Yes. Okay. That's interesting. Okay. Getting 2 or fewer, 0 woman and 1 woman and 2 women. And when it is 11, oh, wait a minute, what is it? 2. Approximately equal number. Oh, equal number of men and women. Sorry about that. So this P is equal number of men and women. So this should be 0.5. I think I did okay in the class. I don't know why I cannot do it here. So this should be 0.5. I'm sorry about that. So this should be changed to 0.5. So this is, okay. So this is 11.5 and 2. Let's do it again. Sorry. So it is clear, 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 clear everything. Second bars. Go down. Go down one more. Okay, it is binom CDF. Okay, 11, comma, 0.5, comma, 2. I get 0.0327. 0.0327. Do we have it? Yes, we do have it. Okay. Now, is it the last one? I hope. Find the probability of at least 2 girls in 10 births. Assume that male and female births are equally likely and the births are independent events. So now what you need to do here, probably at least 2, probability of at least 2 is probability of 2 plus probability of 3 plus all the way to probability of what? 10. Okay, now that's too many, so too much calculation. So what I do, 1 minus probability of what? 0 plus probability of 1. That is 1 minus binom CDF, what is it? NPX. So 10 births, probably of 0.5, just 1, because it goes up to 1. Okay, so showing the calculator. So clear, 1 subtract binom second bars, binom CDF, what is it? 10, comma, 0.5, comma, 1, close parenthesis. I get 0.989. Oops, I lost it. 0.98925, 0.98925. That is almost what? 0.989. Answer is C. Okay, so is that the end of it? Okay, looks like that's the end of it. Okay, thank you. Okay, so